As an instructor, Hal has always stressed the importance of starting all stages of the diver's training in the classroom. Those divers interested in deep diving instruction must first be brought to this level of training through NASDS basic and senior diving courses. Only then are they ready for the advanced knowledge and skill taught in the deep dive program. Hand signals are introduced in class and practiced throughout the training program until they're automatic with the team. During a simulation of a deep dive, Hal receives a narcosis sign. He immediately signals up and makes physical contact with his buddy. Proper understanding and use of diving equipment plays a major role in each student's instruction. An important combination of equipment is the automatic decompression computer, submersible pressure gauge, and depth gauge. The information gathered from these instruments will let the divers know when to start the ascent and assure them of going through the required decompression stop without using their reserve air. A diver's watch and set of plastic decompression charts is used in case of interrupted decompression that requires emergency surfacing. A reel for safety line, diver's knife, and logbook are also used. When making the dive in poor visibility, a high-intensity light is required. It should be constructed to wear around the neck to keep both hands free. A safety light is also carried. Because nitrogen narcosis limits the diver's ability to think clearly and react as he was taught, sharing a single mouthpiece regulator for buddy breathing in an emergency situation becomes more dangerous with increased depth. To remedy this hazard, an octopus regulator is required for all deep dives. With the octopus, divers can easily share air without sharing mouthpieces. A buoyancy compensator with an automatic inflator fed from the first stage of the regulator is mandatory. Neutral buoyancy can easily be maintained with this device without requiring the diver to remove his mouthpiece. One of the most serious signals a diver can receive is out of air. This situation immediately brings into play the use of the octopus and the buoyancy compensator with the auto-inflator to assist in the emergency ascent. Plans for all deep dives are discussed and finalized in the classroom. Depth, bottom time, decompression time and place, air consumption, and advanced knowledge of the dive site and its conditions are integral parts of the dive plan. An example of an instructional deep dive will take Hal and the team to 180 feet in a spring they're familiar with. They're aware of the physical conditions such as visibility, silting, flow, and have planned the dive accordingly. Bottom time will be calculated to meet the maximum air consumption of each member of the team, with the water temperature a strong factor. The depth and time of decompression will be determined by the automatic decompression computer and submersible pressure gauge. An extra tank with an octopus will be tied off at 10 feet for emergency situations. In these scenes, Hal Watts takes a student through a properly planned deep dive.
I make sure the gear is laid out and checked when we first arrive at the dive site. The octopus is hooked up to the twin tanks. The air is turned on and checked to see if it's secure to the valve. Both stages of the octopus are checked for inhalation, exhalation, and for possible free-flowing at the mouthpieces. Our air pressure is also checked to make sure we have an adequate supply of air. We check the safety and primary lights to make sure they are working properly before going into the water. The quick disconnect inflator is attached and the buoyancy compensator is filled to check the inflator and overpressurization valve for proper operation and determine if there are any leaks in the equipment. The weight belt is put on after the BC, and the buckle is positioned for a right-hand release. Make sure the tank buckle is positioned for a left-hand release. A safety tank with an octopus regulator is tied off at 10 feet as an emergency air system. The diver makes sure the air is turned off to protect against possible air leakage before he leaves the tank and makes his free ascent to the surface. Our BCs are fully inflated before we enter the water. Once again, each of our tank valves is checked to be sure they are open all the way. Our PSI is rechecked again. Our entire dive is planned to minimize exertion that would cause excessive use of air and possibly bring on narcosis. All divers must be in good physical condition and have logged several dives, increasing the depths progressively. We have found that in case of trouble, a 3-man buddy team is the safest combination. During training, we always have 2 instructors with each student. In a position over the drop-off, the OK sign is exchanged and the descent signal is given. Air is vented from our BCs and we start a slow feet-first descent. This method is used for better control and communication. The eyes are the best warning meter of anxiety brought on by narcosis. Both of us keep close eye contact with our student during the entire dive. Gauges are checked and rechecked. Hand signals are exchanged between instructors and student periodically to help keep his mind alert. Experience has shown that at depth, an inactive mind is very susceptible to narcosis. So we always give the student underwater assignments before starting our descent. At the maximum depth of the dive planned, the student is settled and the OK sign is given. Everyone reads each other's pressure gauge and becomes aware of the diver with the highest air consumption. This will then become an important source of information in deciding bottom time. We always start our ascent when any of the team shows a remaining pressure of 1,000 PSI. The slate is passed to the student so he can write 1 through 10 backwards. This helps us to test him for mental alertness, and we can tell if he is affected by the increased pressure of nitrogen. After a few minutes at maximum depth, the gauges are rechecked. The student has reached our safe minimum PSI, and according to our decom meter, we must allow for a 10-foot stop. I give the up signal. A control rate of ascent is very important to allow for proper decompression. The student is watched closely to be sure he doesn't overinflate his BC, and a slow controlled ascent is started with a pace of no more than 60 feet per minute, gauged by the lead instructor.
Long hours of proper instruction through NASDS Deep Dive program have opened the way for divers to experience the thrill and pride of making a deep dive. The understanding of technique and equipment have developed an awareness in the students of the many dangers involved in the activity. This awareness is the most important lesson the student will learn, and as long as he respects the strict rules of the sport, he will thrill to many more deep dives.